He worked with many MNCs in the past with rich experiences. Once again, we are very happy to welcome you here, sir. Now I request you to deliver a technical talk on variable frequency drives. Over to you, sir.
Yeah, thank you so much, team. First, I would like to thank IES team, especially Dr. Venkat Ramanan sir, for this wonderful opportunity to share that energy conservation topics. So warm welcome to all the participants for this session on variable frequency drives. So before starting the session, I would request all the participants to mute their lines throughout the session. In case if you have any queries, please put it in the chat box. We have Q&A section maybe in the last of the overall 2 hours session. So I'll just share you what are all the topics we are going to discuss today. We will cover about the basics of VFD, what is there, and how it is working, operation of the VFD, and some of the VFD functions and features, and how VFD enclosure is going to play important role in selecting criteria, and how to size a drive. This is very important for any of the designers, and various selection criteria and applications where and all these VFDs can be used, and how to define the VFD in case if some of them are into design or consultant, or maybe if you are learning how to define the VFDs in various parameters that we are going to see, and harmonics. So this is one of the hot topic of today, harmonics and mitigation technologies. And in last we can cover some of the latest technologies in VFD. So we'll start with some of the basics. We know like only a variable frequency drive, but this variable frequency drive also called various names by different people in the industry. As you can see here, some people will call it as inverter or simple drive, and many of them will call as adjustable frequency drive, AFD, and some of them will call variable frequency drive, adjustable speed drive. So you can see here various names are there, but one common solution is like it is all related to variable frequency drive only. We can call it in different name. So before going into the details of VFD's basics and block diagram, we need to understand how the motor starters and the starting current terminology worked in the history. So we know there are 4 different technologies are available in the starting current of motors. One is the DOL, direct online, and star delta, we used to call star or delta, and soft starters are there. And the last one is of course VFD. We all know DOL is like a simple switch. You can see here that yellow line. So this no control on motor speed, no soft start will take place, and approximately it will consume 6 to 7% of the nameplate current. As you can see here from the graph, this is the power and this is the frequency. So almost 7 times of the motor current it will absorb while starting. And next one is star or delta connections. Again, these also that you can see here that blue color, no control on motor speed, no soft start, and takes approximately 3 to 4 times of the nameplate current. And soft starter, we also know many of them use soft starter. This is just to only at starting and ending, it will give you some kind of frequency control. In between, you won't get any control. As you can see here, only in the starting point, you can get some benefit, but that also not zero. As you can see here, it will consume approximately 1 times. So the better solution available is the VFD. As you can see here, we can able to control speed possible and adjustable throughout the current limit. As you can see here, the starting current is almost to 0. So that is why the VFD plays important role in our market. So before going it, we will see how that VFD operations, basic operation. You can see here, the VFD takes fixed AC voltage. As you can see here, these are the powers from the our EB. It takes fixed AC voltage, and again it convert to AC to DC by using the rectifier, and again it stores as a DC in that intermediate circuit. Then the inverter plays a role to convert DC to AC. But this AC is a variable AC voltage and frequency. So this is why the difference you can see here in red color, fixed AC to variable AC voltage and frequency. So that is what the operation of VFD in simple terminology. As we know, like VFDs varies both voltage and frequency. So you can see here without the VFD, how that line you can see here, it is fixed voltage and fixed frequency here. So we can play with the frequency. You can see the graph changes based on the frequency 90 Hertz or 60 Hertz or 40 Hertz or 20 Hertz. So with the drive, we can able to change variable frequency and variable voltage. So what does VFD do? So as I explained you already, variable speed drive is used to start and control an AC induction motor by varying the speed. So what else can do? It also useful in the process requirement. Some of your process requirement may need to match the speed. Like if you are in industrial requirement, some of the process requirement needs to address. That can be possible by using the VFD, and some application may require the torque. So that can be possible to match the torque of the particular process requirement by using the VFD. And of course, the main motto of the using the VFD is save energy and improve efficiency of your overall system. How does VFD saves energy? So this is very, very important. We know like law of affinity. So this law is like flow is directly proportional to speed and pressure is directly proportional to square of speed and energy is cube of speed. So this is why we are getting huge saving by reduction in the speed. And this is the formula we use like N equal to 120 F by P. So what is N, F and P? We all know like N is the motor speed in RPM, P is the number of motor poles and F is the frequency. So only changeable factor here is the frequency. Say for example, if you are reducing 20% reduction in speed, that leads to 50% of your energy saving. So imagine in any of your critical applications in industry or boilers or maybe any applications, while changing the frequency, you can able to save almost 3 times of the energy. So that's the relation here. So I told you this is the motor control method by using this formula N equal to 120 F by P. And this is the clear example you can see from the screen. Here the number of poles 6, 4 and 2 and the supply frequency you can see it here and the motor speed how it is changing based on the frequency. So it is very clear by using this formula only the changing the frequency we can able to change the speed of the motor. So maybe we can see in depth what is there in the VFD in the block diagram. As you can see, this is the overall block diagram of the VFD. You can see the first section is called rectifier and the intermediate circuit and the inverter. See, while selecting VFD, the two design parameters are very, very important. One is the Rfa filter. We will see in depth in the coming slide what is Rfa filter. And other thing is like DC choke, DC link choke we used to call. That is the main factor for the harmonic mitigation. So we will see in the coming slide what is that and how it helps in saving the current, unwanted current in our network. So this is a simple block diagram of the any frequency converter. If you can take a variable frequency drive, this 3 block is plays main important role. So first section is the rectifier section. I told you AC to DC converter. We are giving AC as an input and the intermediate circuit is called DC bus. I told you already, and inverter section again the DC to AC inverter. So this is the overall function of that VFD, and below that you can find the control unit. So this unit will get feedback from the motor and again it will give input to the VFD. It is like a closed loop. So overall circuit. So this is a basic structure. You can see it in 6 pulse drive. So any 6 pulse, whatever drives we are using currently, Most of them are 6-pulse drive. Why it is? Because you can see here the 6 diodes are there. That's why we are calling as a 6-pulse drive. And already I explained you the terminologies. We'll see in depth what is that there in the each section. I told you the first section is called rectifier section, where it converts the AC power fed from the main to the DC power by using the diode bridge rectifier. So here we are using the diode or maybe the SCR based on the kilowatt rating by converting AC to DC. This is what the main function of the rectifier section in any VFDs. The center section is called DC bus section, where it is very important to you know where we need to store the DC power, and also this section consists of capacitors. You can see here capacitors and inductors to smooth the ripples whatever we are getting and store the DC power. We can able to store the DC power and we can give it to the next inverter section whenever it is required. So in a simple terminology, this DC section will act as a receive, store and deliver DC power. That is what the main functionality of this DC bus section. And this section also having two chokes. We call it as a DC choke. We will see what is that function and why it is required in the VFDs in the coming slides. So this is what this section. And the last one is inverter section. I told you, like, again, DC to AC inversion is required because we cannot use the DC to variable voltage and frequency. That is why again we are converting DC to AC by using this inverter section. So what the main equipment or maybe the device used to convert to DC AC is IGBT. We know IGBT is like a switch. You can see it here. It is nothing but insulated gate bipolar transistor. It is a solid state switch, just on and off, and it is act like a very fast, high power switching device where we can get in any of the equipment. So in a simple terminology, why we are using frequency converter? I told you, like, we can avoid product damage because if no VFDs, we know a lot of wear and tear will be there in the machines and a lot of mechanical resonance will be there, and we can avoid downtime. If VFDs is there, we can have the backup and we can avoid the downtime and added flexibility in any of your applications, and of course the energy savings. And one more is like reliable stopping and synchronization. Whenever you want to stop, we can stop, and synchronization is also possible by using the VFD. And whenever the demand is high, that time the VFD plays major role, because whatever application we are seeing here is all variable load conditions, because we design for the maximum load, but we end up with using in the minimum or maybe the lesser loads. So that is the variable load conditions, whatever we are using in any applications. So that is why VFD plays major role in your application to reduce maximum energy, whatever possible. And the power factor is also very important in any application, that VFDs also help us to improve the power factor in your applications. So not only that, and the VFDs also give a lot of protection to your equipment in related to overcurrent, over voltage, under voltage, and it is giving earth fault. So many options are available in the VFDs that will protect your equipment by using this VFD in the motor or the fan applications. So what are the selection criteria? So this is very, very important because we should know how to select the VFDs, because in the market you can find like various drives are available, because if you see some of the makers are having a common drive for all the applications, but here some of them may have application specific drives. If you can find more relevant drives for your suitable your applications, example, if a thermal plant or maybe the HVAC applications, so more relevant drives are available. So we need to know how to select the drives. So these are all very important factors you need to keep in mind for selecting the drives. First and foremost, the type of applications. For what applications you are going to use, whether it's a torque applications, variable load or variable torque. So we'll see in the coming slides what is that. And the motor data is very, very important, whether what is the temperature production required and the current and voltage frequency, speed, everything we should know. The motor nameplate data is very, very important for selecting the VFD, and the installation area where you are going to install these drives. And the respective IP means ingress production. We all know that. So that is also important role actually while selecting or defining the VFD. And air quality, because the area where you are going to install the VFD, that is also very important, because if the area is more corrupted, maybe it is near to sea areas, we need to see and select the appropriate VFDs. So that is also very important. And the cooling, type of cooling while selecting the VFDs, and the cable length, that is very, very important between your VFDs and motor. How long that cable length, that is also you need to keep in mind. And of course, this vibration and supply voltage. So these are all parameters related to installation data. And the temperature, what is the ambient temperature? If say, for example, drives can able to withstand up to 50°, if some areas may go above 50, then we need to select or derate the drives. So that is very, very important. And the altitude and the switching frequency, this is also very, very important while selecting the VFD. So these are all selecting criteria I told you. So based on the three methods, soft starter and DOL, VFD, I told you, and we need to define how we can select. See the major criteria, if you can see here, the initial cost of VFD may be high, but here capex and the OPEX means operating cost. You can see the operating cost of DOL is very high, and soft order is also equally with VFD, but the VFD's operating cost is very, very less. Maybe the initial cost may be high, but you will get the return on investment very fast by using the variable frequency drives. So these are the major selection criteria in terms of applications, what type of applications you are going to use, whether constant torque or the variable torque or the constant power. So these are all different applications requirement available, and the installation location where you are going to install, like inside the control panel or maybe in the open terrace direct to sunlight. That is also very important. You need to see that, and how you are going to install, whether it's a wall mounted, that is also very important. You are going to mount in the wall or over the edges. So those kind of parameters you need to see while installing the location. And of course the budget, what is the capex and opex, we need to see that. And the electrical, any requirement in terms of harmonics and any standards are there, you need to see that. And the end use, what is applications like hospitals or data center or any industry applications, accordingly you need to define the VFD. I told you there are different load characteristics are there. First and foremost is the constant torque applications, where you can see here 150% overload capacity is required for these applications, and the constant power like CP, we used to call CP, that is also there. And some of the applications what we are using as the variable torque applications, where the overload capacity is requirement is 110%. We'll see one by one what is that. Constant torque application is nothing but the amount of torque required is independent of the speed. So that means the HP requirement varies linearly with the speed. Some of the examples like conveyor, mills or cranes and elevators. So those are kind of a constant torque applications. Here what happens, the drive overload capacity required is 150%. So you need to keep in mind for these applications, the drive should have capacity of withstand 150% overload capacity. So accordingly, you need to select the model for this kind of applications. So variable torque application is the majority of the application will come under fan and pump applications, where you can see here the amount of force required varies the square of the speed we see in the starting of the slides. So here the requirement is 110% only, where you can go straight away with the requirement. And constant power application is nothing but where you can see independent of speed and torque, the work to be done. So that is why this kind of application will come, like example, winders or the drilling machines or your grinders, all those things will come under constant power applications. So to summarize this, different load types equipment are there based on the starting torque or current. You can see here the variable torque applications. Some of the examples I told you, axial fan or centrifugal fan or pumps. So these are the requirement: 40%, 30%, or 50% the starting torque, and the constant torque in the application like compressor. Most of the compressors, conveyor, mixers are 150% full load amps. So this constant power, I told you example, machine tools or electric cars are 100% and 50% based on the application. So this is very, very important point you need to keep while selecting the VFDs. And VFD enclosure is also very, very important because we know IP rating and the NEMA rating is very, very important for any of the equipment to work for the long time. So here the VFD is also having different parameters to select based on the enclosure. We will see what is that. Why we need to consider the importance of drive enclosure is we know protect people from dangerous voltage, because what happen if you select IP00, then no production with any of the solid or liquid, then people may touch and it leads to a lot of dangerous things happening at the site condition. So we need to see the different chassis and NEMA productions available in the market. You can see clearly in this slide actually. So here IP represent ingress production. There will be a 2-digit always, we know, whether people used to call 20 or 55 and sometimes 66. In the VFD terminology, what standards we have is IP00 for some of the rating, and IP20 we have, and even 21 also we can give for some of the kilowatt ratings, and IP55 within the drive also we have, and IP66 where you can directly install in the roof direct to sunlight. So those kind of IP66 enclosure also we have. So what it means actually, you can see the first digit refers to the solid object and the second digit refers to liquid. So meaning that if you are selecting, say example IP20 drive, so 2 means production again solid object up to 12.5 mm. Example, only our fingers cannot go inside, that kind of production it will give you. So 0 means no production against liquid. If small drop of water maybe over the if goes over the VFD, then VFD may able to fail it. So that's the reason the 0 IP20 is not recommended to install in the open space without any kind of panel. So always people go with the panel IP42 or maybe even IP55 we have. Here you can see protected against dust. So no harmful deposit across the VFD. So complete protection you can able to get in the IP55. And in terms of liquid, you can see you can spray any jet of water from any direction. So no water can go inside. So this is the industry recommended like IP55 and even IP66. Some of the applications like water application, marine applications and all require this kind of IP66 requirement where totally protected against dust. And here you can see strong jet of water. Even you can put VFD under the water also. So nothing will happen. So it will completely protect your VFD. So 66 also available up to certain kilowatt ratings, 90 kilowatt maximum. So these are all the standards related to IP definition. So we need to keep in mind where we are going to install and what kind of IP rating we need to select based on the application and the location. So this is very, very important for any of the VFDs. Is anyone having some queries? Can you just mute?
Yes, sir, I muted.
Yeah, thanks. So how do you size a drive? Okay, we know how to define the enclosure that we have seen. How to size a drive, or maybe what is the thumb rule behind the drive to select? We all know like HP is there, kilowatt is there, full load ampere is there, and constant torque, variable torque. We all see all those things. But simple thumb rule is we can select based on the motor kilowatt. As you can see, the motor kilowatt, say example 7.5. The thumb rule is you can straightly select 7.5 kilowatt VFD, variable frequency drive. But only thing what you need to look, the current, the full load current of that VFD drawn by the motor should be equal or higher. Then only it can match. But as a general thumb rule, we will design equal kilowatt of motor, equal VFD rating. So that is what the thumb rule says. And we can design in such a way that. Okay, so what VFDs can do? So we have seen it can able to start and stop the motor by using local or remote, and it can able to adjust your speed of the motor to match what is required, your flow or pressure or temperature, whatever it may be, we can able to play with that. And it also provide you gentle ramp up or ramp down to eliminate these surges or mechanical, electrical, whatever it may be. So that is possible by using the variable frequency drive. And I told you like smooth operation. The starting of the VFD, it's very less. It consumes very less power. In case if no variable frequency drive, the starting current of the equipment will be very high. By adding the variable frequency drive, you can able to see the difference. The starting current will be very less, and also process improvement will be there. And less wear and tear, I told you already, like the equipment life will be increased by adding the VFD. Because if there is no VFD, what happens suddenly the equipment will go high speed and again comes down, again increase, again decrease. So it leads to the motor life very less. A lot of wear and tear will be there in the equipment. So those things can be avoided by adding the VFDs. And I told you a lot of production, it is giving over voltage, under voltage, all those things possible by putting the VFD in your applications. So not only that, VFD is also having a lot of communication protocols added in that. So by adding that communication protocol, what you can do, you can easily communicate with your applications. Say for example, if you have BACnet or maybe MS or maybe Profibus, whatever it is. So VFD can able to easily communicate with your protocol, and it saves you a lot of time and the big process involved in that. And of course, the last and foremost, the saves energy. VFD can able to save energy that we have seen. So this is just example how the VFD nameplate data looks like. So if you are if you are getting any chance to see the VFDs, you can find the nameplate data in any of the VFDs, maybe in the top or maybe the side, where these are all the parameters you can find, and you can easily identify whatever we have seen here. So the first one is refers to the model number of the VFD, FC302, meaning that the model number, and K55 is nothing but enclosure rating. So I told you IP55 is there in the VFD. So this nameplate data, this VFD is having IP55 enclosure. So like that, there are so many technicalities are there in the VFDs in terms of your applications where we can able to select. So this is the complete description available in any of the VFDs. And this is the part number for any of the companies to refer in case it is under warranty or the warranty is over. We can able to find out by using this part number and the serial number. And here you can see the chassis IP20 or the ambient temperature 50 degrees Celsius it can able to withstand. So all this data available in the VFD nameplate. Okay, so we will see some examples. VFDs, where and all VFD can be used in typical buildings. Say for example, here I considered the commercial building applications like your hospitals or hotels, where you can see the VFDs can where and all can be used. We know like in some of the big hotels, there will be escalators or elevators will be there. So there also you can find the VFDs, variable frequency drive, under the elevator or escalator, wherever you go, shopping mall or maybe in your metro applications, or maybe the big commercial complex. These all elevators and escalators having the variable frequency drive. And of course the cooling tower in the top of the building, where you can find the cooling tower also can be used with variable frequency drive. And if you come to the plant rooms in the bottom of the buildings, we can put VFDs in the chillers, because the chiller is the main equipment for cooling the entire building. So there we can use the VFDs, and the pumps, whatever pumps is their primary or secondary, those also we can use the variable frequency drives. And in terms of basement applications in basement car parking or the kitchen ventilations, so those also we can put our VFDs. Exhaust fans also having VFDs requirement. And of course the AHUs, air handling unit, you can find in each floor. So there also we can put our VFDs. So this just example how and where we can use VFDs in typical buildings. So now we'll come to see the interesting part of how to define the VFD. Suppose if you are going to select or design the VFDs, so these are all critical parameters you need to keep in mind. First and foremost, I told you already that IP rating. So what is the IP rating of these VFDs? So this is a just a variable frequency drive here you are seeing, and this enclosure is IP55, and this is the display. You can see all the functionalities in the display, like what headsets is running and which direction motor is running. All the details you can see in the display. And this switch is nothing but front disconnect switch. So what it means that in case any problem in the VFD, you can able to switch off the power, individual VFD power by using this button. Because if this button is not there, you have to go to the main switch or the main EB, then switch off the VFD. So many of the latest VFDs are coming with this front disconnect switch, where you can simply on and off, the power will be goes, and it is very useful for the service people can go inside and they can do their work without switch off the main. So that is the importance of this disconnect switch. And the cooling efficiency system, that is also plays very important in defining the VFD, because we all know this is an electronic device. It can produce some of the heat in your areas whichever you are using. So how efficient your VFD can able to exhaust the heat or eliminate the heat, that is also very important. And of course the efficiency part plays very important role in any of the equipment you are selecting. So here the VFDs majorly you can find a greater than 97% efficiency. So that is also very important while defining the VFD. And there will be two filters inside the VFD which plays important role in your applications, any of your applications. One is nothing but EMC filter. EMC is nothing but electromagnetic compatibility. People used to call RFA also, radio frequency interference. So this is nothing but, suppose if you are using your mobile near television or landline, you will get some kind of noise or disturbance. So same thing will happen in any kind of electronic devices. Suppose, for example, this VFDs you are using inside your industrial applications or hospital. Say for hospital, what happen? There will be a lot of sensitive equipment in the hospitals. Say for example, X-ray machines. So many sensitive equipment will be there, and this is also electronic device start interact with those kind of sensitive equipment. So this leads to maybe misreading of X-ray machines, and it will affect both the equipment together. So that is why we need to arrest the interference at the equipment level. So there are some standards are there, IEC 61800, to define which type of filter needs to be selected based on the application. So that is why the EMC filter plays very important role while defining the variable frequency drive. And of course, the harmonic is also very big topic because VFDs is having a lot of positives, and one more negative point is like it also produce harmonics. That is unavoidable because we know whenever AC to DC conversion is there, that equipment will able to produce harmonics. So that harmonic mitigations also should be part of the VFD as a basic level, because we cannot control entire harmonics inside the VFD, but basic control should be there inside the VFD. So that is also very important for defining the variable frequency drive. So first and foremost, I told you the enclosure rating and the installation location, that is very important. See here you can see there are two different technologies or type of installations. This is a traditional system, very old system people use. where a big panel will be there, and they will put variable frequency drive inside the panel, where you can find it here. This is the variable frequency drive, and inside the complex panel, where you can see a lot of wiring, cable, and so many equipments are there. So this leads to what happens. Suppose if somebody kept the panel open, so it leads to a lot of issues and failure of the VFD, and a lot of losses will be there by going with this traditional panel inside the VFD. But the latest one, what we recommend as per the standard, is wall mounted drive. You can simply directly mount in the wall. It's IP55 production, directly mount in the wall, and you can avoid the space, whatever required for these big panels in any of your applications. So this panel can be completely removed, and you can paste, maybe mount in the wall, or maybe over the equipment also possible in the current VFDs, because now the size of the VFDs are drastically come down compared to older systems. So by using the VFDs in the wall, you can save a lot of space in your installation areas. So this all can be eliminated, and cost wise it is very, very effective. So that's why we are suggesting this kind of installation, where you can save this panel cost and the complex wiring and relevant losses, whatever is there. So I told you that the heat management is very, very important for any of the VFDs in your applications. So how efficient your VFD in terms of heat management? Say for example, if you are designing VFD for any of your applications inside the air conditioning room, say for example, suppose that tonnage, maybe the TR requirement is 7. By putting this big VFDs inside the room, that will also add the heat to your tonnage and increase your tonnage. Maybe if 7 become 8 or 9. So to avoid that, what some of the VFD manufacturers are offering is like, we are also having back channel cooling, or maybe the duct cooling. So what meaning that whatever this VFD produces the heat, it will be directly taken to the ambient. Means it won't mix within your air conditioning load. We can take up to 70 or 80% of the heat produced by the VFD by using the back channel cooling, because all these VFD having this back channel cooling, the heat dissipation will happen in a natural way, and it won't mix with your electronics. As you can see here, the two different colors. So this is the electronic part of the VFD, and backside, this is the backside of the VFD, where you can see a lot of fins will be there, and it doesn't have any electronic equipment. So it's a natural ventilation happening. Whatever heat it produces, it will come and go in the upward direction, as you can see clearly in these pictures. So this kind of technology is required for any VFDs in terms of better heat management. So that is very, very important for any VFDs for selecting. So two important topic I already touched up, EMC and harmonics. This is very, very important, electromagnetic compatibility and harmonics in any of your applications. So there are standards I told you, IEC 61800/3 2004. So they are defining some category of the filter. So what is that means? Categories C1, C2, C3, and C4. C4 is the lowest mitigation filter, and C1 is the highest mitigation filter available in the industry as per the standard. So what it means, suppose if you are selecting any VFD, any critical applications like hospital or data center or any of sensitive applications, we need to go with this category C1 filter. Otherwise, what happen? There will be interference within your electronic to electronic interference will be there. To arrest this category C1 is mandatory, that we can able to take up to 50 meter between the motor and your VFD. So that is very, very critical for any of your applications. Say, imagine if it is an airport application, you are going to install the VFD. Say, example, in any of your airports, VFDs is installed more than 100 numbers. Imagine the 100 VFDs also can able to create that noise disturbances. Say, for example, if any pilot is giving some information to the airport room, So these VFDs can also disturb their informations, or maybe the pilot, whatever he tried to say. So there is a chances of human life involved in that. So that is why it is very, very important to keep this factor while designing the variable frequency drive. What kind of filter needs to be there inside the VFD? This standard is recommends we need to keep inside the VFD as a factory inbuilt. Based on the application, you can select category C1 or C2 or C3 or C4. They are also differentiating different parameters. So this is just example. I already told you what is electromagnetic interference. So if at all in the same line, the same UPS or maybe the monitor, and if you are putting your cleaning equipment, the both will interact and there will be noise. So same thing will happen in terms of radiation as well as conducted. Both interference will be there in your electronics. So that is very, very important. You need to take care of this both by keep in mind. So how they are segregating is first environment and second environment. So what is mean? First environment is nothing but our applications like residential area or commercial applications are used to comes under first environment. Second environment is nothing but the industrial areas where the people have their own transformer substations. So those kind of application does not require this critical EMC filters. Maybe we can go with C3 or C4 for industry applications. But here the commercial building or residential area, we need to have C1 or C2. That is very high sensitive areas, because what happens, this equipment are connected directly to the public low voltage mains. So a lot of equipments will be connected together. So it will affect and interact each other. So it is very, very important. We need to select the category of filter. So this is just example of that noise. We measure this in dB only, noise level created after putting the filters. The red color one is the C1. You can see the noise level will be very, very less, 50 to 60 dB here. And C2 filter means it will be somewhere around 60 to 70, and 90 for C3, and 120 for C4. So this is the difference between the four filters. Okay. For any equipment, safety is very, very important, because we all know many humans involved in that, and we need to keep in mind how safe your equipment. So in VFDs also we considered that, and there are a lot of safety features available in terms of functional, and we are also having fire mode. Say imagine if VFD installed in your application industry or whatever maybe, if fire happens, the VFD can able to overrule all the alarms, and it can able to run your fan in forward and reverse direction to exhaust the smoke out of your building. So it can withstand up to 70-degree temperature for 1 hour, and it will overrule all the alarms and act as a fire safety equipment. So that option also there in the VFD itself. And seismic complaints, we all know in case of any earthquake or flood, the equipment should withstand those kind of natural hazardous. So all these electronic equipment should be as per the standard compliance. So VFD is also one of them in that. And this lockable integrated main disconnect. So what is mean this switch only? I told you already, this is a on off switch kind of thing. So what happen if any of your site it is installed, if someone comes and directly changes the direction, it leads to a lot of unwanted thing. So we are also having logout tagout, meaning that you can put small lock, kind of a safety lock here, and no unwanted people can touch without our knowledge. So this lockout tagout is available for this equipment for safety purpose. And this is about the environmental safety. And the enclosure we already discussed, and the ambient temperature is very, very important. Suppose if you are using this drive in the low temperature areas, even the -1, the VFD can able to withstand even -10 degree, and the maximum 40 degree without derating, and we can go up to 50 or 55 degree with derating. So that is possible with the variable frequency drive, and the relative humidity in the range of 5 to 95, that is available. And aggressive environment, I already told you, by using this, we can go with various coating is available, 3C3 or 3C2 to protect your PCBs from the aggressive areas. So this is also important factor you need to keep in mind. Okay, so this VFD can also used as a standalone device for any of your critical applications. Suppose if you are using in any complex applications of pharma or maybe industry applications, this VFD having inbuilt PID loops, meaning that there will be a 4 PID loop. By using this PID loop, we can able to control any of the external HVAC devices or maybe the industrial application devices through the VFD. Any query? Yeah, so by having this 4 PID loop in the VFD, we can able to control any of the external HVAC devices like chilled water valve or hot water valve or the temperature sensor or damper. You can able to control with the help of the VFD. No need to have any external equipment in the BMS system. So these VFDs are highly intelligent. You can see here the example of such applications. Say for example, that air handling unit inside the building, you can see here the requirement, IO requirement is somewhere around 17 points. All this can be eliminated and it can be processed through the VFD, meaning that we are having that add-on card. By putting that add-on card, we can able to eliminate this complex design. The VFD can able to act as a single equipment. You can save a lot of energy and cost. So that is possible with the help of the VFD alone. And in terms of tools, how VFD can able to program or how it can be transfer the data, it is same like our PC, like whatever we are using desktop. It also having a USB port where you can see it here. You can directly connect with your laptop. So whatever program you have done in the VFD, you can able to take the backup by using this MCT10. We are having that MCT10 software. By using that software, you can take the backup. And for programming, it is very, very simple. This display can be removable. You can remove and copy paste with the multiple drives. That is very, very easy for any of your applications. This coated PCB I told you because if you are using VFD for chemical applications or maybe seashore areas, so this PCB needs to be coated for any harsh environment. So that option is available in case if your application demands, you need to select whether 3C2 or 3C3. So those kind of options available. And this variable frequency drive also having the display that I already told you in the starting itself. It having two options, graphical and numerical. So this graphical display is nothing but this one where you can see any 5 parameters in the display itself. Say for example, what is the headset is running and which direction motor is running and what is the amps, what is the kilowatt, everything you can see in the display itself. No need to go inside and see. So this is the kind of display available in any of your variable frequency drives. And one more interesting feature in the variable frequency drive is real-time clock. So what it means, we can able to trigger any actions. Say for example, if you next week if you want to clean your AHU filter or your boiler or whatever may be the applications, you can able to trigger those actions in the VFD. It act like a you will get alarm. So suppose if you are putting your trigger for next week Saturday, I want to clean my boiler, then the VFD will give you alarm. So this is the time and you can trigger 20 actions through the VFD. So it will eliminate your need for external BMS because whatever functions you can see it here, you can do through VFD. You can save a lot of cost in the BMS. And one more interesting thing, we are talking about energy savings, all those things. So in the VFD itself, we have these options of energy monitoring. So this tool is very, very useful. What it means, suppose if you are putting variable frequency drive in your applications, from day one, how much energy you saved. So those kind of information you can get in the display. Suppose you can select that options of energy monitoring tool. You can get to know from day one of installation of VFD how much energy you saved in your particular applications. So those can be taken as a printout, or maybe you can see in the BMS. So that will really help you to convince with your management or whatever it is. So that is very really helpful for any of application, because we are talking about energy saving and energy monitoring. So how we can prove that? So this tool inside the VFD can able to give you that idea how this is happening. And some of the interesting functions in the VFD is like broken belt detection. What is mean? If suppose any of your applications, any belt is broken, and the VFD can able to give you alarm. So what means that we will set the torque of that belt. If any changes in the torque, you will get the alarm. So this will eliminate your external sensor or wiring required, whatever it may be, we can do through the VFD itself. And one more interesting thing is flying start. So what is flying start? This is nothing but if suppose any power goes, say for example, the VFD is running at 50 Hz, power goes up, and again within 1 second the power comes, means the VFDs will not start from zero. It will catch the last running RPM or the heads. It again starts from that. So you can save that energy. So that is why this option of flying start is useful in any of your applications. So now we'll see what are all the different terminologies like harmonics. I told you it's very, very important whenever you see the variable frequency drive. We'll see what is harmonics and how it can be mitigated. See, in a simple terminology, so the ideal current wave is like this only. So what happens in some of your applications, maybe harmonics will be there. Harmonic is nothing but simple definition is unwanted signal in your power system. So what happen, your ideal waveform will be distorted like this. You can see it here. So this will lead to a lot of issues in your transformer, or maybe any of your cable heat. So many issues this will provide. So wherever you are using maybe the equipment like VFD or maybe UPS, because this harmonics is produced not only by VFD, also by our normal bulbs. Even the bulb also can produce harmonics, and UPS, so Xerox machines, all those things will produce harmonics. But whenever the VFD's higher kilowatt ratings are there, then the harmonic level will be very, very high. We need to take care. Otherwise, it will affect your system. So in terms of harmonics, there are two different signals. One is the voltage and current. Because voltage is a system dependent. We don't need to bother about voltage harmonics. Current harmonic is the major because that will damage your equipment. So we need to take care of the current harmonics. So what happened? So what is the current harmonics? How it affect, and what is the standards are saying? There are some standards. IEEE 519s are there. IEEE 519 2014 is there. So they are also defining some requirement for any of the buildings. And suppose if you can take here in Tamil Nadu, the local EB also putting some standards. The THID should be less than 8. Otherwise, if more than 8, they will put penalty. So the local EB people will come and measure that harmonic level in your premises. If it is above 8%, they will put penalty. So it is very, very important to keep our entire building under control because of harmonics, because we need to see and study the harmonics. See, normally this harmonics is nothing but is a nonlinear device. Wherever nonlinear devices are introduced in your premises, then harmonics will be there. So this harmonics can occur at the odd multiplies of the power frequency, example 50 Hz in our case. So only the odd heads will get the harmonics. So that means that 5, 7 and 11 and 13th order will be the more stringent. So we need to take care of this order of harmonics 5, 7, 11 and 13. If you can able to arrest this, you won't get any harmonic in your system. So this is the standard I told you, IEEE 519 2014. So what it recommends is there are some ratio like ISC by IL. ISC is current short circuit and load. So this ratio should be less than 20. Then your current harmonics can be allowed up to 5. If it is between 20 to 50, you can able to maintain 8. So like that, they are defining some ranges, and accordingly you can able to go with the current harmonics, total demand distortion. They used to call it TDD. So again, the current harmonics also a major role here. So that is why it is very important to take care of the current harmonics within this limit. These slides will give you clear idea what is current harmonics and how it act with different equipment. Say for example, if we don't have any inductors or any choke inside the VFD, in the starting slide I told you VFD is having DC choke on both the side, positive and negative side. So just imagine if there is no inductors or no choke, then your typical current waveform is like this, and your THID at 100% load will be somewhere around 100 to 120%. So imagine I told you as per the local EB, it should be less than 8%. So without DC choke, typically 100 to 120. So that is why it is very important to keep DC choke in the VFD. The starting slide I told you DC choke plays very important role, because the basic mitigation method is the DC choke. If at all, if you need less than 8% or 5%, then we need to go for external filters. So there are a lot of options available, whether active or passive. So that equipment needs to be selected based on your applications and the load and the current harmonic percentage. So we can do it at equipment level, individual VFD one filter, or maybe we can combine 3-4 VFDs, we can put one filter, or maybe we can put it in the source. Source means PCC, point of common coupling we used to call. There we can put one common filter for the entire building. So those kind of different options available. Imagine if you are using AC choke inside our external, then typically your current harmonics at 100% load will be 35 to 45. Then I told you some of the manufacturers are using DC choke. So with DC choke, you can able to maintain 30 to 45% within drive, because within drive for smaller rating, this much current harmonic only possible. Suppose if you are using it for higher kilowatt applications like chiller or maybe higher compressor applications, then we have options like low harmonic drive. So meaning that within drive we are having the filter as a module. So we can able to offer you less than 5% or 8%. And so many filters available. I told you passive filters. In the passive filters, there are a lot of options, AHF 010 and 005. So that can able to maintain up to 10% or 5% based on your requirement you can select. But only disadvantage is in the passive filter is you can able to put individual filter for one VFDs only, because passive filter is for the individual equipment. You cannot use it for the common solution. And of course, we are also having like 6 pulse drive. We are also having 12 pulse and 18 pulse drive. So based on the matrix, so this will help you to reduce your harmonics. So if any of your applications, you can see it here, the kilowatt, ideal kilowatt also mentioned in that last slide. Suppose if a 250 to 1400 kilowatt, then probably we can go for 12 pulse drive. Then your harmonic level at 100% load will be 12%. So 18 pulse means even it will reduce further 6%. And we are also having some new technologies called AFE, nothing but active front end. So any kind of regeneration required for your applications where you can use this active front end drive, you can able to maintain less than 5%. So these are all different methods or mitigation techniques available to mitigate the harmonics. Okay. We'll see some of the latest technologies available in the drives. First and foremost, we all know the industries are going with high energy efficient motors and also the fans. So many people know, like now the latest trend is the plug fan, and people used to call EC fan. EC fan is nothing but as a complete module where you can find motor, fan, and the controller inbuilt. As a module, you can find as a EC fan. So that is the latest trend available in the market. So to counter that, some of the new technologies what we developed is EC plus. So what is EC plus is nothing but the combination of three high efficiency equipment, where you can see here axial fan we are using for any of air handling unit where the efficiency is more than 90%, because normally axial fan we use it for car parking or basement ventilations because the noise will be very high. But this axial fan, whatever we are using, is very highly efficient and low noise. So it can be used for our regular applications. So this efficiency is 92%. And motor, if you can take now a lot of new technologies like PM motor and even that IE5 motors available in the market. So by taking that motor, you will get 95% PM motor efficiency, and the VFDs, of course, 97 or 98%. So all the equipment you can see here above 90. So the total system efficiency, whatever I'm talking here, the 85% is the total system efficiency. We can get 85% compared to maximum available in current industry is 70%. So, but we can able to give 85% by this combination. So what means like overall system efficiency comparatively 15 to 20% improvement we can do by this new technology with the axial fan, PM motor, and the drive, because this four plays major role in improving the overall system efficiency. So what difference makes axial fan gives 92% is the blade tip clearance. You can see here it is aerodynamic design, and only our visiting card can go inside here in that edge of the blades. So they have done in such a way, and the efficiency wise, that is why it is giving better, and noise is also in control. So this is a typical plug fan I told you available in the market, where you can see here it's a module, motor and a fan and the inbuilt controller. By using this EC fan, no need for VFDs. You can able to control in the equipment itself. It's a small PCB controller available, not like full-fledged VFD, but you will get some basic controller. So here the drawback is like the airflow. You can see here the air comes in and bend and goes up. So that is why the losses is very high because of this EC fans available in the industry, where system efficiency maximum 60 to 65. But here in terms of our solutions like axial fan with the normal VFDs and the PM motor, you will get 80 to 85, because the improvement in overall system efficiency we are talking here 20% is very high in any of the applications. We also done the testing in the third-party lab TUV. So what we did actually, we took two AHUs, one with plug fan and one with this EC plus, what we are calling with our axial fan and PM motors. So you can see it here. This EC plus solution is 2.3 meter less in terms of the length. You can see this is very bigger because the plug fan size is very big, but our solution is very compact and very small. see 1018 kg, this solution is less compared to the traditional AHU with the plug fan. So you can imagine this kind of difference, and accordingly the efficiency also plays important role. So this is what the overall system efficiency, whatever I explained, the operating load, even in the different load conditions like 40% or 60%, even 80%, you can see the difference is very, very minimal. So this is a very, very proved technology available in the market. You can go for it with the axial fan. So almost 20% energy saving because of the axial fan. One more interesting add-on features in the VFD is pressure transmitter unit, PTU we call. So what it means, like there are some standards, eco design, European directives. So what they are telling, like starting from 2018, any big equipment you are producing like AHUs or whatever it may be, this should have inbuilt controller to monitor your filter status. Say for example, if you are using the AHUs, there will be filters, HEPA filter or pre-filter. So many filters will be there inside the air handling units. So that filter monitoring, like the filter clogging status needs to be monitored by the VFD itself. So then you can save a lot of energy and you can able to improve the efficiency. How it is possible? Because you need to clean the filter at right time. Because if more clogged, then that is also problem. Yearly cleaning also problem. Then we need to clean the filter at correct stage at the correct time. So that is why this equipment, add-on equipment, where you can connect in the bottom of the VFD, where you can find it here. This having 4 input, you can take from the AHUs different filters and you can give as an input here. This will give you alarm, because if suppose if this filter is more clogged, you will get alarm in the VFD itself. So this is the industry European eco design recommended as a energy saving equipment part of the VFD. So we all know, like industry is going to 4.0 and everybody wants very intelligent solutions and smart equipment. So Drive's also having that new technology called condition-based monitoring. We all know the idea of condition-based monitoring is to detect the potential failure before an actual failure occurs. So how it is happening? Because it takes the actual feedback from the sensor. Because normally we won't take any feedback based on the sensor. It depends on the external equipment. But now the VFD is acting like an intelligent drive. It can able to monitor your stator winding and the vibration of the motor and the load pattern of your system. So all these 3 parameters we can able to monitor through the VFD. So that is why condition-based monitoring is very, very important, because there are a lot of solutions available. Like we also know different technologies are available, like preventive maintenance or maybe the predictive maintenance and corrective maintenance. So all these are different roles are there, but condition based monitoring is such a strategy used in the latest industry 4.0, where actual sensor data is used to determine the condition of the equipment in service. So meaning that we can predict the future failures and it will give you correct alarm when you need to replace and what is the condition of the equipment. You will get on time information in the VFD itself. So all these things parameters can be possible through the IoT. So we are all talking about the IoT terminology here. So that is also possible with the VFDs. Because what happened now, all the equipment are acting as a very intelligent. So this drive also can be used as a sensor. So the latest drive, whatever is there with the condition based monitoring, can be used as a sensor to maximize your uptime. Because if it is not there, then you need to go for external sensor, then a lot of complicated cable wiring, so many parameters are required. But by adding this small features or maybe the software inside the VFD, it can able to give you correct time for the replacement of the any equipment. So this is the latest thing in terms of condition-based monitoring. So one more new intelligent drive feature is the fire mode. I told you VFD is having basic fire mode, and we are also having enhanced fire mode. So what it means, like say for example, some application, example tunnel application, you can take metro tunnel. What happens if that is very highly sensitive applications? If any fire happen inside the underground metro stations, it leads to so many damages because it's underground. So the fire smoke can able to spread across all the equipment, and the VFD should play important role there. So what it means, like we are also coming up with enhanced fire mode. This is having 32 predefined operating modes. So meaning that we can able to get data from 8 different zone. So this VFD can act as a equipment. It can able to take feedback from 8 different zone, and also it can act as a whatever functionality I told you, like in terms of overruling all the alarms and give you collective feedback, and it can act as a sensitive equipment. And more or less this can be controlled through the field bus. Suppose if you are using any BMS or SCADA, through that we can able to monitor and control. So that option is also possible. And of course, I told you for any kind of tunnel applications, this requirement of 70-degree ambient temperature for 1 hour, we tested our drive. It is working because we know when fire happens, the temperature, ambient temperature is very high. So these equipment should withstand the temperature. So the latest drives, whatever developed, it is having this capacity to withstand 70-degree ambient temperature. And also we are having this wireless LCP, because we all know now everybody is using the smartphones. So what happened now, we have software available like in Android or iOS, you can able to download. And in case these VFDs are in the unreachable areas, say for example, if it is over the roof or somewhere where we cannot reach the VFD, you can able to control or monitor parameters through your mobile phone. So that is what it is. The latest standards are saying, like wireless LCP. So this LCP can all the readings or programmable data, everything you can control and monitor through your smartphone. And also we are also having some of the LCP mounting kit available. Suppose if you are using the VFDs inside the AHUs or maybe the panel, that LCP mounting kit can be used where you can mount in the door panel. So those options also available now. So I covered most of the things. In case if you have any queries, you can come up.
Yes, sir. Participants, if you have any doubts or if you have any question, now you can discuss.
Hello.
Yes, sir. Your voice audible. You
Yes,
can.
sir. Sir, I just have a query. Like
Yeah.
this VFD drives, can we use these VFD drives for in the hazardous area like fuel oil pumps, pump area, pump house, or in the gas stations in?
Yes, sir. That's what I told you. Like we are also having that corrosion environment. Only thing you need to select accordingly that coating. Like there are different coatings available inside the VFDs to protect the card. Like 3C3 is the highest coated available. You need to opt for that because that will not come as a standard. You need to request the manufacturer to give that protected coating. So if you have 3C3 coating, then the VFD can able to withstand any hazardous, example, the chemical or maybe the seashore areas. So those kind of things it can withstand. We have a lot of examples where the VFD is still running in that hazardous areas.
Thank you, sir. Thank you very much.
Sure.
Thank you, sir.
दो ही तो सेशन हुआ है।
If any other participant has any questions, you can proceed.
Hello, sir.
Yeah.
Hello. Yes, sir. Sir, is it possible to get the harmonic level in the controller itself? Like, what is the harmonic level in the VFD drive system?
No, actually, we are having harmonic measuring equipment. Power analyzer is there. So through that, we can able to measure the harmonic level by using that equipment. In case if you are going for higher kilowatt ratings, like I told you, low harmonic drives and all, that will give you information in the display itself. Like we are having active filter and drive in the same module. So that in that you will get to know what is the
scan பண்ணி email
I think someone can mute the line, please. Yeah, so that in that LHD you can able to see that low harmonic drive in what is the harmonic level present in the things you can see in the display, but not for lower ratings. Less than 90 kilowatt you need to use the power analyzer, external equipment to measure the harmonics, because there are a lot of equipment available where the third-party vendors also there, where they can study the entire system and give you data, because it is very, very important to take the entire overall plant under our control. So by using the power analyzer is the best way.
Thank you, sir. Thank you very much, sir.
Thanks.
Participants, any other doubts?
Thank you, sir. Venkat sir, it was an excellent lecture, sir, on VFDs and its applications. In fact, the participants would be benefited with your case studies and examples and all, especially the harmonic component of it, because the earlier session they were having some issues on the harmonics. So this was an eye opener for them, and it will be quite helpful for all, sir. Thank you, sir.
Yes. Yeah, thanks a lot, sir. Thanks a lot.
Thank you, sir.
Thank you. Thank you all. Thanks for all your time.
Shyam?
Yes, sir.
Yeah. My screen is at.
Yes, sir. It is visible, sir. Yes, sir.
Good evening to all. Second day, the last session, because I'm having some additional time, whatever that is left over by the speakers. So I thought till 4:30 it is there. Probably I'll be able to cover the third chapter of it. The other two, probably if I have time, then accordingly I'll be able to have it done. See, in the first first session, we have seen about the Indian energy scenario, what basically it is, and coal-based inputs, how it was, and renewable energy, how much amount of power we have from them, and what are the fuel mix pattern that we have, and how the energy generation pattern had got altered, and the consumption-wise, how it has happened. And now we'll be able to see the environmental impacts of these energy aspects. The first aspect or the first environmental impact, what we people would be aware, is global warming. Almost all of us would be aware about this one, global warming. Second, ozone hole. Let us understand how it happens, then we will see how it could be avoided. First one, global warming. As you people would have seen, the interiors of the car, as I was explaining earlier, the interiors of the car, irrespective of the time, it will always be warmer to you. The temperature, whatever you have at the interior of the car, as compared to ambient temperature, what that is prevailing in the interior of the car will be higher than what that is available in the ambient. Any answers why so? What makes the interior of the car to have a higher temperature as compared to ambient temperature at any point of time? Any inputs? Sham, am I audible, Sham?
The heat is
Yes, sir. You are audible, sir.
Yes, sir. Fine, sir. Yeah, of course, I was able to have an answer. The heat is?
oh, sorry, sir. The heat is trapped inside by the solar radiation, because it is the watts per meter square. That is the intensity of solar is trapped inside the car.
Yes, sir.
With
Okay.
respect to the
See,
intensity.
yes, sir. Yes, sir. True, sir. In fact, an glass layered room, it is called as greenhouse. A glass layered room, it is called as greenhouse. The feature or the characteristics of this glass is it will be able to allow short waves, rather whatever waves that we have it from sun, they will be high energy waves, or in other words, their wavelength will be in short. This is an example of a short wavelength, or this is a high energy wave. The high energy wave has the ability to go through the glass. This is case one. Once when this high energy wave goes through this glass, and once when it hits the interiors of the car, it will be able to lose its energy. As a result, it will become long wavelength. The same period of time, if this is called as T, the same period of time it will be like this one. It will become long wave. Long wave will not have the energy to overcome the glass layer. It will get trapped inside. It will be re-reflected back. As a result, it will be re-reflected back. As a result, the interiors of the car will become warmer. Hence, the interior of the car will be at a higher temperature as compared to ambient temperature. I repeat, the waves, whatever we have from the sun, 1 minute, please. Yeah. Sir, I'm in online class. Is there anything else now? I'll call you, sir, after this, please. Thank you. Yeah, okay. Now, the rays, whatever we have from sun, especially the beam waves, beam radiations, it will be of shorter wavelength. It has the energy, it will be able to go through this glass. It hits the interiors of the car, it will be losing its energy. Transformation happens. As a result, the short wave will become long wave. The long wave will never have the energy to overcome the glass, hence it will be re-reflected back. As a result, the interiors of the car will become warmer. Sir, how far this is attached with the global warming? Yes, of course, it is attached. The analogy is same. Whatever the effect the glass is having, same glass will be exhibited by carbon dioxide. Whatever thing that we people have seen as of now, that same effect will be replicated by carbon dioxide. This has the same tendency. It will be able to allow the short waves to pass through. It will not allow the long waves to pass over it. As a result, it will be re-reflected back. Hence, global warming happens. Okay, this is what I was informing you. Probably the atmosphere will be having, and the CO2, whatever we have from the hydrocarbons, whatever fuel that we have, all are hydrocarbons. So the carbon content upon oxidation, carbon plus oxygen, it will give abundant amount of heat energy, carbon dioxide, and it's an exothermal process. And approximately 8,800 kilocalories of heat energy would be available for every kg. So much amount of heat energy would be available. and this carbon dioxide will be settling on the atmosphere. It will be having the same effect as it of the glass layer. See, now initially carbon dioxide was available, but of course the level of the CO2 was lower. As a result, some amount of heat was entering in and some amount of heat was reflected back. However, once when you burn all these fuels which contains carbon, it will be having higher emissions, and that higher emissions will be having higher layer of CO2 like this one. The CO2 layer will become higher. As a result, a re-reflection happens. The temperature of the earth, it will become higher. It increases. Okay. Now, if we see the thermographic image of the globe, 100 years before it was like this, and now it is like this. Okay, now you would have understood. And this is a scientific proof how the temperature, how the mean temperature of Earth had become higher. Like earlier it was like this. Probably if you go for progression, it goes like this. Now, how this affects or what happens?
Sir, the slides are not changing, sir.
Slides are not changing.
We are still at same slide.
Sham?
No, sir. It is okay, sir. Slides are changing.
How about others? Apart from that participant, how about others?
It's changing, sir.
Changing. Okay, sir. I think there is some problem with your thing, sir. Probably you can log out and then you can start again, sir, if you don't mind.
Okay.
Okay. Now here, whatever we have, this is one normal statement. What they inform, India is among top 5. This is what every person, whomever you meet across international conferences, they tell like India is among the top 5 things and all which emits CO2. Like, of course, this is a true fact, but actually what we people have to understand is how much does every individual Indian emit. Per capita CO2 emissions is the one what we people have to tell. Per capita, how much does every individual in India emits? If at all we do that analysis, India is much lower as compared to other countries. So it is not on top 5. It is down the whole list. Like, okay. Now there will also be another statement. What they feel like, if CO2 isn't there, then it would have been okay. No, it is not so. If CO2 isn't there, the earth would have been a frozen ball of ice. If the CO2 isn't there, the earth would have been a frozen ball of ice. No survival would have happened. The CO2 buildup had increased in temperature. As a result, survival had happened. As a result, we are able to live. Like, and the present level of CO2 in the atmosphere, what we people speak about is 365 parts per million. Okay. Any idea how much parts per million makes 1%? Any inputs? How much parts per million makes 1%? 10,000 ppm will be equal to 1%. The intention of informing you this one is, we are speaking of CO2 level of the order of 0.0365% in the atmosphere. If this level becomes 0.04%, then the impact will be too huge. Just understand the quantity of CO2 what we speak about. As you people would be aware, for doing stoichiometric analysis, we assume that air will be having only O2 and N2 alone. O2 we take it as 21% by volume or 23 by weight. N2 we take it as 79 or 77. This is by volume, this is by weight. We neglect the other gases. The other gases are argon, CO2 and H2O. These 5 things would make our atmospheric air, but we neglect these 3, informing that they are too low a value to be accounted. Stoichiometry will never get affected with these analysis. Like, but here, the presence of CO2 to such a marginal level will cause havoc. Probably I'll be able to inform you what those havocs are. It will be much helpful. Like, now, these are the 6 gases, which has the same effect as that of glass that we have seen on a car. Share wise, if at all we see, carbon dioxide accounts for almost half. Among the greenhouse gases, carbon dioxide accounts for almost half. Fluorofluorocarbons, which are obtained from R22, refrigerants, R12, R22, all those things, it will be there. Now we will see these things and all. These are occurring naturally. They were in existence earlier, but these are the emissions what we people have made, which has created havoc like, and we will see how it has created havoc and what are the impacts of those things and all. Before we go all those things and all, you people have to understand a term called as global warming potential, GWP. GWP. As you people are aware, among the various greenhouse gases, the presence of carbon dioxide accounts for greater than 50%, almost half will be this one. So we take the global warming caused by 1 mole of CO2 as a base, and then we equate all these gases on this one. We equate all these gases on these things. For example, if you take methane, the global warming caused by 1 mole of methane will be equal to the global warming caused by 21 moles of CO2. So what do we do is that we assign global warming potential GWP of methane as 21. Rather, what we do is that we equate all these gases with the global warming that is being obtained from CO2, and we compare it. If you do that analysis, it becomes easier. Sulfur hexafluoride, 1 mole of sulfur hexafluoride would be causing a global warming that would have been obtained by 24 tons of CO2. Clear? Just see these things are all under whatever I told you, CH4, methane. So we take the CO2 as the base, then accordingly we'll be equating all these gases with the CO2 as a base. Okay. Now these are the ill effects. Of course, all of us would be aware, like global warming. One classic example is the rain what we people in Chennai have experienced just 2 months back. Like the rain which should have been for a period of 1 month, if it comes on a day, then flooding will always happen. And people attribute it to El Nino effect, and that could also be attributed to global warming. These are the various aspects, like, and probably if at all you want to see the actual fact in India, these are the real things what we people in India will encounter. Rajasthan will be encountering more amount of drought. Gujarat belt, the sea level rise will be there. Mumbai, saltwater intrusions will happen. Coral bleaching. Yeah, in fact, this is a major problem in Andamans now. Coral bleaching, Ganges, all these things and all are there. Probably with images, it becomes much more easier. Like Kulu Valley at Himachal Pradesh, the apple belt has moved 30 kilometers north. Rather, the temperature had become higher. So the area where the apple was available, it isn't able to grow now. As a result, this has moved upwards, like, or else rather the area which was apple area had become barren now. They are not able to cultivate anything over there now. And Ganges, this you would have seen, like the Gangotri glacier, it is melting at a rapid rate, and some of these might disappear with this existing rate by 2030. Probably with this image, it becomes easier for you people to understand what the length initially was and what the length initially now is. And now probably it would have been somewhere here. But here, the rapidity or the growth of CO2 level is increasing in an exponential way. Hence, Conference of Parties, COP, had become in existence. Kyoto Protocol, all those accords had become, and as a result, people are trying to lower their emissions. So the impact will be so, and I think you would be aware, if this glacier goes off, then the water supply for China will be affected, for India will be affected, for Nepal will be affected, Bangladesh also it will be affected, because the Ganges will flow through those areas and all. So all these areas will get affected. Like coastal Orissa, 5 out of 7 villages have submerged. That is also one important factor what you people have to know. Okay. Now, the norm wise, it has been established like for every 1 unit of electricity India makes, 1.2 kg equivalent of CO2 is being emitted. For every 1 unit of power, whatever India generates, it has been arrived like 1.2 kg equivalent of CO2 is emitted. Now, this value comes from this. Probably I'll go to some slides before. I'll tell you how this value had been arrived like. So now you people would be aware like out of the power, whatever we generate, out of the energy, whatever we generate, 70%, 75% was obtained from coal. So what do we do is that we mix, we arrive at all these things and all. Gas will be having some amount of hydrocarbon. Diesel is having some amount of hydrocarbon. Biomass will be having some amount of hydrocarbon. And coal is also having some amount of hydrocarbon. The energy mix would be available. From that one, the composition of these things would be available. If it is coal, carbon content would be available. Carbon plus oxygen, it will form CO2. I'll tell you one small example. 12 kgs of carbon requires 32 kgs of oxygen to form 44 kgs of CO2. So 1 kg of carbon will be able to emit 44 by 12 times of CO2. Likewise, we'll be able to estimate the amount of carbon content that is available inside the fuel. Accordingly, we'll be able to establish the amount of CO2 what we'll be able to emit. So CO2 from coal, CO2 from this sector, from this sector, from the other sector, all these sectors will be accounted. All these sectors will be accounted, and then accordingly we'll be able to arrive at the energy mix like. 1 minute, sir. Sir, online class, sir, or 10 months, I'll call you, sir, please. Yes, thank you. Yeah, okay. So these are things what we people have seen, and the live examples were, it was also informed. Yeah, the next is ozone. So the first one, global warming, it was understood. Second one is ozone. As all of us would be aware, the atmosphere can be divided into 3 broad regions: troposphere, stratosphere, mesosphere. The stratosphere is the one which will be lying between 10 kilometers to 15 kilometers. 10 kilometers above the earth, it will be available. From here till 50 kilometers, it will be there. So this is the layer what we people speak about like. And here you will be having an pungent smelling light bluish ozone gas. Ozone gas is already existing in the atmosphere. Ozone, as we people would be aware, it is O3. As we people would be aware, it will be O3. This has the ability to save us from harmful ultraviolet rays. The ultraviolet rays, whatever that comes from the sun, it will be filtered off and it will not be allowed onto the earth, like it gets filtered here. Now, what happens to the ozone? Ozone was existing, and ozone, it will be occurring in equilibrium. The equilibrium is like this. It forms and then it dissociates. It again forms as such. Now see here, ozone was existing. The ultraviolet ray from the sun was able to have an impact over here. It was able to dissociate into oxygen and monoatomic oxygen, O2 and O, at a lower wavelength. Now here I was able to split down the ozone into O2 and O. And again, this O2 plus O at an wavelength of 240, they'll be able to merge together. It will form O3. So there exists an equilibrium wherein the O3 gets dissociated into O2 plus O, and this O2 plus O will again recombine. They form O3. So this equilibrium was existing. As a result, the ozone layer that was available above our atmosphere was intact. We were safe. Now, the ozone depletion substances, which we address as ODS, they'll be having a very high impact, especially the chlorine, fluorine, bromine. These halogens will be having a high impact. Like, the issue is that they don't get dissolved with water. During rain, if they get dissolved, it becomes easier, but unfortunately, they don't get rather they remain suspended in the stratosphere. As a result, what happens is that one chlorine atom will be able to dissociate approximately 10,000 to 1 lakh ozone molecules. Probably I'll be able to tell you how it is so. This CFCl4, CFCl3 over here, with the help of ultraviolet rays, it gets itself dissociated into CFCl2 plus chlorine. This chlorine will interact with ozone. As a result, it will disintegrate the ozone into chlorine oxide plus oxygen. That is here. As a result, you have chlorine oxygen over here and you have oxygen over here. This, what happens is that this attracts another oxygen. Already one ozone molecule has been depleted off. As a result, this ozone molecule has been taken down into O2. Now this, again, this ozone would be in equilibrium because it will be able to combine with another O. As a result, the ozone, it would have formed. But unfortunately, this ClO will interact with this oxygen also. As a result, it will again recombine itself and it will form Cl plus O2. As a result, the equilibrium, it will get affected. The same thing, what I had explained to you, all those things are available over here. The equilibrium, it will get affected. As a result, the layer, whatever you have, the ozone layer thickness, it will become lower. That we address it as ozone hole. The thickness of the ozone layer, it is informed by Dobson meter. Dobson is a unit what we address like. If the thickness is lower, the ultraviolet rays available at those areas, it will become higher like. So, and thinning of the ozone layer will indicate higher ultraviolet rays onto those areas, and this has higher impact on our health. It will be having different impacts on various aspects like and these are the other impacts of ozone layer. Okay, now the second last one. What are the options that are available with us to lower the environmental impacts and also to lower the energy gap what India faces? I repeat. Here, as of now, we have seen about the energy issues that is associated with India, energy demand of India, and how much amount of fuel that we people import. How much amount of fuel that we people import, and apart from that one, what are the issues that is being associated with the current energy mix pattern? Okay, now probably if you people can inform the options, it becomes easier. Any inputs? What are the ways through which we can have these two things averted? One is that how the energy gap can be lowered and how the climate change can be averted. Like. Yes, sir. Any options, sir, please?
Sir, can we use the renewable energy so that the energy gap, whatever it is, can be reduced with respect to the non-renewable sources?
Excellent, sir.
Excellent,
sir. Excellent, sir. Excellent, sir. So the first option is go for renewable energy. As a result, the energy gap, it can be avoided. It can be averted, and it will also be environmentally benign. So it is advantage number one or option number one. Second option.
So there are two ways. One is like from the supply side by using renewable energy sources, and other one is from the demand side. If we start doing the demand side management.
Yeah, of course, demand side management. Of course, it is true, sir. Probably we can go in for the class. What we people are attending now, we have to save energy. Energy saving.
Yes.
Energy saving is third one. It is option number two. Third one, we have to go for alternate technologies through which we'll be able to have additional sources of energy. These are the three things. These are the three things through which we'll be able to lower our energy gap, and also we'll be able to make our environment a safe place to live. We have to embrace renewable energy. This is option number one. or you can lower your energy consumption pattern. You can go in for energy saving, or you try to innovate new technologies whereby you can improve the energy scenario and also you can make the environmental a better place to live. Like onto this, we are having our energy audit. Onto this, we are having our energy audit. The last part. Okay. Encon and energy efficiency, whether these two things are same. Whether these two things are same, one basic thing what we people have to understand is that energy efficiency is a part of Encon. One classic example I can tell you. Replacing an incandescent lamp with a fluorescent tube light or a compact fluorescent lamp, this is nothing but your energy efficiency. Replacing an incandescent lamp with a compact fluorescent lamp, you are able to improve because with lower amount of input power, I am able to have higher amount of light. So that is nothing but your energy efficiency. Switching off a lamp where it is not required, that is Encon. Conservation of energy. Energy efficiency also will be part of this Encon aspect. Energy conservation aspect. Now, this is one basic thing what people have to understand. Almost 75% of the people wouldn't be aware about this one. I'll tell you one classic example. It becomes much helpful also. Here, what I wanted to ask you is how the energy conversion happens from fuel source to light. We will go step by step process. Then it becomes easier because the previous speaker or the earlier one, I have seen that he was addressing like 1 unit of power, whatever we say will become equal to 2 unit of power, whatever you generate. Probably after this example or after this exercise, you will be able to understand it is not so. We will see how it is not so. Okay. First one, what we do is that we have a boiler. Typical Rankine cycle power plant. Feed water comes in. Feed water absorbs the heat. As a result, it will become steam. The steam comes. It goes and expands onto a steam turbine. The output power will come. You have an alternator. Mechanical energy gets converted into electrical energy. Accordingly, we'll be able to export them. The low pressure steam, what that comes over here, will be taken back. Condenser would be available. Seawater would be taken in. It will be able to absorb. We'll be able to convert this one into water. The low pressure, low temperature steam would be converted into water. Accordingly, the whole phenomena happens. I think yesterday, second session, Dr. Sethumadhavan was able to address you onto this aspect. He was telling you the energy losses, what happens in all these things and all. Okay, now we will see this one. This is case one. This is case one. Now here the power is available at this end. I have a house which is located far off. I have a house which is located far off. Onto which the intention is to glow an incandescent lamp. Onto which we have to glow an incandescent lamp. The mechanism, what we do is that we have a step up transformer here. The power would be available here. Secondary coil will be able to have it across. Secondary coil will be more. This is step up transformer. The power gets boosted up. Voltage becomes higher. Current becomes lower. As I was informing you, the intention is to make I square R loss to be lower. This comes through the grid. Then accordingly, at the user point, I'll be having a step down transformer. This is step down transformer. And from here, I'll be able to take the power to the lamp. From here, I'll be able to take the power to the lamp. Now, we will see how the energy gets converted from here to here. So that it becomes an eye opener for you all. The input, whatever we give is 100 kg of coal. The input, whatever we give is 100 kg of coal. So 100 kg of coal, I gave it here. As we people are aware, the typical efficiency of a Rankine cycle power plant will be approximately 35%. typical efficiency of a Rankine cycle power plant will be approximately 35%. In other words, out of 100 kg of coal, whatever I had fed in, only 35 kg equivalent power will be available here. I repeat, out of 100 kg of coal, what that was available over here, only 35 kg is available as equivalent power. The remaining 65 I have lost elsewhere. The remaining 65 I have lost elsewhere. Now again, this will be available over here. I have to step it up. Transformer efficiency. Anyone who can inform the efficiency? Any idea? What is the typical efficiency?
85%, sir. 85 to 90.
90.
My God.
5% transformer efficiency.
Sir, please, sir.
Transformer efficiency 95%.
Yes, sir. Okay. See, the efficiency of a transformer would be 99 plus, sir. In fact, we go for amorphous core, whereby our insistence on efficiency has to be 99.5 plus.
Okay,
Because
sir. Okay.
transformers, no mechanical components are involved, only induction happens. So the efficiency of these transformers has to be high. Right now, amorphous core are being used, like, as a result, the efficiency becomes 99.5 and above. So from 35, if I have a conversion efficiency, I take 99%. So 35 into 0.99. So 34. Here I have 34.65 kg of coal equivalent. As we people have seen, like T&D losses is 20%. As we people have seen already, T&D losses, whatever we encounter is 20%. So here it becomes 34.65. This multiplied with 0.8. Only 0.8 will be available over here. So what I get is only 27.72 kg of coal at the downstream side. Out of 100 kg of coal, what that was available over here, at the end user point, I'm having only 27.72 kgs of coal. Now, if we take an incandescent lamp, the incandescent lamp coil will be like this, and this will be covered by an bulb, by a glass layer like this. As you people would be aware, the incandescent bulb would be able to convert only 10% of its input electricity into light. The remaining 90% would be available as heat. The incandescent lamps, they convert only 10% of their electricity into light. The remaining 90% would be discharged as only heat. So out of this 27.72, only 10% equivalent will be available as light. So approximately 2.7 kgs of coal equivalent I'll be having at the downstream side as compared to 100 kg of coal, whatever that we are having it at the source line. So just have it in mind, like it is not 1 kg equivalent to 1 or 1 kg equivalent to 2. It is much higher than that. It is much higher than that. So whatever power that we save at this downstream end will help us to save a lot of coal. Apart from that one, it will also help us to save on the CO2 aspects also. So have these things onto your mind, it becomes much helpful. Okay, this is one aspect. Okay, now on the technical aspects of, I think it is 4:30. I think we will stop for this one. Then we'll go in for the next session. Whenever we have some free time, accordingly, I'll be able to engage you all. Any doubts? Clarifications, please. Any doubts?
No, sir.
Yeah, I think I should also inform you how we people take the attendance. Like probably you can see the screen where we have it across, where I'm addressing you all. We have a link over here. I can click over here. I can go for download attendance list. The attendance list would be downloaded. Then I'll also show you how the attendance will be available. It will show at what time we people have logged in, at what time you people have left. All those information would be available. So that's the advantage of the MS Teams software. So ensure that you people attend all the sessions, because as per AICTE norms, we have to update the attendance like. Clear? Thank you all. We will Tomorrow morning at 9 o'clock. Sharp, we'll meet again.
Thank
Okay.
you.
Thank you, sir. Thank you, sir. Okay.
Thank you, sir.
Thank you, sir.
Sir, when can we expect the PPTs? Will we get the PPTs?
Sir, what you are asking? PPTs, sir?
Oh, yeah.
Sir, PPT, please share.
Yeah, sir. So in the Atal portal itself, they have provided some provision for us. So we will upload that. Okay.
Atal portal, sir.
Yeah. So you have provision. Also, we will share at the end of this FDP, sir. Because we are collecting from the experts, surely we will share the slides.
Sir, WhatsApp group in.
No, WhatsApp group as well as to your registered email ID, you will get it, sir.
Yeah.
Yeah, because we cannot able to share one by one, so I will compile all the PPTs. Then final day, I will share to you all. It will be easier for me also. Thank you,
Okay,
sir. Sure, sir.
Sir, registration forms only feedback form only.
Yes,
Not
sir. We are taking attendance in the MS team also, sir. Okay, so now what sir have discussed, the same way we are taking each session attendance as well as we are seeing the feedback come attendance form also, sir.
first day only fill only feedback form, not fill registration form.
No, you are Atal registered participants. So actually this is only for Atal registered participants. Those who have registered through website, they only eligible to get the certificate, sir. There is no separate registration form for this FDP.
Yeah, Atal registered
Yeah,
registration
registered
already.
through Atal, you will get the certificate through the same Atal portal.
Atal already done, sir, registration.
Okay, sir. Then no issue. You will do the process whatever available in your login, sir. Thank you.
Sir,
One more thing I need to.
Sir?
Sir, there will be an exam at the end, right? There will be an exam or what?
Sir, one by one, sir. I'm not getting.
Sir, at the end, there will be an exam, right?
Yeah, sir. Yeah. 80%.
Okay, sir.
Those who are getting 80% attendance, they are eligible to write the exam as well as you have to score minimum 60% in the test. That is the criteria you have.
So actually, if either the video recording or something, many times because of network issues, we tend to there are time lapses sometimes, and even I just got my email in the junk at the very beginning. So the first two sessions I missed actually. So because of that, I just gave it. I wrote it in the WhatsApp.
Sure, sir. No. That's why in the first day, if you have not got the mail, right? So that's why we have shared through Gmail. So feedback link to your mail, we will verify. Okay. So first day, we will try to account the feedback form alone because 4 to 5 members have messaged personally to me regarding this issue. So
yes, and I have also missed the sessions also right
Hello?
now.
Sure, sir.
Yes.